Good morning, everyone. Wow, where is my teleprompter? Jeremy, where's my teleprompter? What's going on? Well, my name is Michael Connolly. Ronan Connolly is my son. Willie Soon, I don't know who the guy is, obviously. In any way, joking aside, we are from the Center for Environmental Research and Earth Sciences. My target audience is not only you sitting here, and also those who eventually watch the video. My message is very simple. Science is very powerful and very beautiful. You have to make good use of it. We should spread the message of science. Do not be afraid of anything, right? We can do a lot of stuff with science, and we should tell only the truth and nothing but the truth. We will show a lot of slides here, so I'm going to take you a crash course. Unfortunately, that's my style, to come to a Willie Soon talk, meaning that you have to learn some science. There's a lot of details, but I think it is the details that are actually going to empower you to be able to discuss with your neighbors, Al Gore, whoever that wants to talk to you about climate science, right? You got to tell them what's wrong with what they are thinking about, or even the evidence, so-called evidence that they're showing you. Anyway, please come visit www.series-science.com. Series is spelled C-E-R-E-S, okay? All right. This is my 25th years of speaking straight in this meeting, so I'm very proud to be here. And I wanted to introduce the meeting in the sense that we will have Michael Connolly follow after me, and then Ronan Connolly, they are father and son team, as you know, and Imelda Connolly, the mother, is here too. And we have my good friend Jonathan Kohler, the great clarinetist. And then we have Jerry Pollock, we have Craig Rucker from CFAC, Christopher Farrell from Judicial Watch, that's doing so much for America. And then Shane Connor, I don't have a picture. The whole purpose of coming to this meeting is to take a picture of Shane Connor so I can put it up there. And then Larry Bell, my good friend from University of Houston. And then, of course, Stephen McIntyre, he's probably not here yet. And then Ross is here, Ross McKittrick, I saw him in the morning. And then Warren Kadinsky, I hope I pronounced it properly. And James Armstrong, Norbert Rempe. And then, of course, the great Art Robinson. Now, we have a special guest today that I haven't mentioned yet. But when I look into the famous history of what we do here and the DDP and the Oregon Institute of Science and Medicine, we have a project called the Global Warming Petition Project. And you look in there, you'll find a name, the guy named John Francis Clauser with a PhD. Well, he's here at this meeting. We are so honored to have John Clauser here. And indeed, he was awarded for his great experiment that was done in 1969. That was a beautiful experiment. And he was awarded a Nobel Prize in physics in 2022, not the Peace Prize, by the way. Let me tell you what's the relevance of John Clauser. This is the original thinker. We have this project, Global Warming Petition Project, but he already signed this long ago. So I found out, we even got the envelope. Where he sent from, we got his address, but I blew it up. But he signed it in 1998, so he's the OG, what we call, the original guy, right? Who signed this thing. So we're very proud to have this project that actually essentially trying to debunk the idea that science is based on consensus. Because IPCC, the United Nations Intergovernmental Panel on Climate Change, always says that they have so many of these scientists, this and that, right? We say, well, we can get a lot of scientists to sign these things. You know, on our petition to say that CO2 is not harmful, CO2 is this great gift of life, and we should not be trying to cut CO2 emission. In fact, it's dangerous to do so. We also have some other people that signed this thing. Jonathan Kohler is one of them. We got your envelope, by the way. So you signed it in 2007, Jonathan. And he is a very well-trained physicist, by the way. And then we, as far as I remember, I can check. Jim Armstrong is another guy that signed this petition project. So we're very proud that all of you are here and you'll be speaking. So please listen attentively to them. Probably not my talk, but I'll do my best. Okay. Before we get into talking about this, what we call scientific challenges of the detection and attribution process by IPCC, I want to provide some latest new evidence that we don't talk about too much. In fact, it's good news. The global CO2 emission from man part of it has been flattening for almost a decade. How many of you know that? It's actually not rising very rapidly. This is actually a shocking fact, right? And then if you look at the US one, by the way, the main reason is because the previous estimate of the land use component, instead of the dashed blue line, the old estimate, the new one is actually showing that it's been decreasing. And that by a large proportion, so that when you add them up, it's actually flattening for already a decade or so. So this is somewhat of a surprising fact. Then if we are more US-centric, you see how much we've been, actually our CO2 emission has been, well, it's because of Biden economy, we're actually not doing too much. We've been decreasing by 18% since 2005. Please try to understand this. The idea that they've been trying to sit into school kids and all of us is that you decrease CO2 and then you're going to actually reduce the concentration of carbon dioxide in the air. To do what? I don't know exactly. This is why it's so flawed, the idea. For the US, we have done just about everything we can, unless we really decided to put a gun on our head, right? It's terrible. But what happened in all this time? Actually, the CO2 emission, concentration of measurements of CO2 concentration in the free air, not in the room here, there's a lot of high concentration because of my breathing. You can see that actually it's been rising. And you know what? I call that very good news. You all know why the reason is the good news, right? It's very simple. I report to you now one of the latest publications, I think it appeared in April of this year. There is a paper from Nature. By the way, Nature is supposed to be a very prestigious journal. And it shows that the planet is getting greener. So the data is up to 2023. So this is providing some update. For those of you, again, I remind you, if you want to use this slide, please take the slide and use it or modify it to the way that you want to use it. But this is good news. So planet is getting greener. And that's why CO2 is plant food, right? And it's a significant thing. We won't read that, but I tell you that it's a very good news in that sense. And then if you want to look at the distributional details, you can see that over equatorial Africa, northern Australia, Midwestern US, Europe, India, and China, all getting very dark green in the sense that the greenness are getting more. If you don't like planet to be green, I don't know what you want to do with it. I think this is a good thing in that sense. So I'm not going to argue with these people who say that they don't like the planet to be green. So we can accuse them for not liking green planets, right? So essentially, it is a story of basically the snail complaining to the frogs that you are too heavy. And then the frog is complaining to the turtle or tortoise that you are too heavy to hold me up. So it's a very strange situation. And now we'll talk about the detection and attribution. By the way, this way of framing is the IPCC way. As true scientists, we don't necessarily agree with it. But I'm going to play along and try to explain the flaw process in the IPCC thinking or not thinking, right, basically. You know, first of all, to talk about global warming, you have to know how you measure global temperature, how you detect that, and then to find, after you see global warming, you want to find out what is causing the change, so you call attribution. And then some people call IPCC, as you know, infinite profit for the climate crooks. I think I will start using that instead of Intergovernmental Panel on Climate Change. It's a mouthful, but this is simpler. Well, IPCC is well known. It's in the sense that it's performing very serious science. We call it cartoon science. It's a bit like a thing that you call D-science with the trademark on it. And then whereas normal people like us, we know just science, you know, we're just doing science, nothing too fancy about those things. So we need to learn more. What's the problem with the IPCC perspective? Well, we do have a scientific puzzle. This is something that actually been endeared to me because we've been trying to learn. How does it work? If climate change, why does it change? If the sun may have something to do with it, then how does it work, right? It's a very deep puzzle, and it is a very difficult thing. In fact, because if you keep following IPCC paradigm, which is doing cartoon science, and then a whole lot of shaking and then nothing happened, that's kind of bad stuff. So we want to know what is the real science? What's the true problem here, right? Let me quickly now go over quickly the outline. Again, we will talk about detection and attribution. The first approach is basically what is the detection involved? It's basically examining what the thermometer data means, right? So we will do that carefully, and then we'll talk about all the details problem. Let's not worry about it now, but really remember the word homogenization and urban blending. These are the only two things you need to remember. And then the attribution part, we will show you how IPCC is so nice that they have a very biased kind of, everything they do is just strange thing actually. Have nothing to do with science, by the way. So they would recommend you that to use only one particular measure of the solar irradiance, which is the measure to try to study climate change. And then we actually say that you have 27 of them instead of 1. And then, let me see, this guy moved by itself, but of course we'll talk about our latest results. What do we find? That was published about last year, right? In September and October, 2 papers together. And then I'll offer some conclusion. The first step is to understand what IPCC is about, right? If you want to call it infinite profit for the climate crooks, it's fine with me. But they were created in 1988. It's a UN body, you know, run by the World Meteorological Organization and the UN Environmental Program. One of the most important things that I think is sort of bypassing a lot of people is that their foundation is actually based on the thing to say that they actually want to provide scientific information that politicians can use it to develop climate policy. So from day one, it was never ever about science, isn't it? They've been very successful in the sense that they produced 6 assessment reports so far, from 1990 AR1 to the latest one, AR6 2021. Just in case you are curious that they're going to close the shop tomorrow, no. The next one, AR7 is coming. That is scheduled for 2028. So let's pay attention, right? The Heartland Institute has done some great work to try to preempt that in the 5th assessment, 2013, in the sense that we were able to produce the non-governmental interpanel for climate change and IPCC about 3 weeks, I think, Joe. We beat them by 3 weeks or a month before that. We had that event at Heritage Foundation. But anyway, the most iconic statement of IPCC is that global warming, at least since 1950, is mostly human caused and also unprecedented. So how do they reach the conclusion, and is it scientifically justified? Here's the detection. Here's a measure of global climate change, basically. It's a thermometer based on thermometer record, and they show all kinds of color, meaning that from different groups, and they're all trying to act as if that this is very powerful science, that is totally independent, but it's totally bogus in that sense that everybody use the same data sets and then they do the same thing, more or less. And then, you see, this is the kind of deception in the sense that it's not true, right? It's not independent, really. So in that sense, we have to kind of challenge them. I will explain why this particular curve is wrong, obviously. And another important thing is that our US is just going worse and worse and worse and worse. We have a thing called the US National Climate Assessment. How many of you know about this? Yeah, only a few, right? You know, less than half of you, or 20% of people know that. But they just produced a report. For a long time, for almost 20 years ago, there have been only 13 agencies. Since we are in El Paso, Texas, I have to mention that the 14th agency was added February of 2023. It's the Department of Homeland Security. They have, as if they have nothing better to do, that they joined this group. And look at the kind of statement they made in their chapter. No natural process known to science could have caused this long-term temperature trend, meaning that curve that they were showing. It shows you how embarrassed to make a statement like this. The only credible explanation for the observed warming is human activities. It is really definitive. You got to pinch me, you know, to make me believe that this is somewhat of a fake thing. Before we do that, I want to prove to you that we definitely can do what they did. So more or less the same curve, but now we're speaking in terms of Northern Hemisphere. We will explain why global is really not global, because there's just not much data. When you have no data, you cannot insist that you have the global coverage. Mainly the Southern Hemisphere, the oceans and all that, we basically got no data. Okay? So remember that. Don't let them use you. Don't let them win even an inch, because it's not global. It's Northern Hemisphere. That's the best we can do. That's all. And our black curve is actually, we can independently do that. And then the rest is their curve. By the way, there's a lot of this group from England, from Japan, from what have you, you know, from Berkeley, the prestigious university. You have all kinds of things. But we can get exactly what they get. Isn't that a good step? And then I want to explain you, the only way you get that, the only way, is that you have to have the thermometer station at the urban area and the rural area. You add them together and then you got this mixed bag of something. I don't know what this is, by the way. It's not measuring climate change, in my humble opinion. So later we'll explain what this urban heat island effect phenomenon is, right? But to be assured that IPCC is so confident, this is the chapter 2, you know, in that particular page of 42 and 44, they did make a very strong statement that this phenomenon of so-called urban heat island effects affecting the thermometer measurement is very small, they say. You almost can neglect this. because it's less than 10% of the trend, right? That's a very confident statement. But the question is that how good is this statement? IPCC, you can easily, in fact, I'm sorry, there's nothing to pretend. It's just nonsense, the kind of statement they make. And then you will see later, as we explained in the video that we want to show tonight, that was made by my son, Ben Soon. And then Roland was explaining that this thing has been going on since the fourth report, since 2007. They've been trying to say that urban heat island effect, everybody know, right? It's kind of too hard to ignore that. But the effect is so small, so you can forget about it. We are still right, okay? But we will show you why they are so wrong quantitatively. So how does IPCC approach on attribution to try to assign causal factors? First thing they use is basically, well, they need the measurements, they need the temperature records, so they use the one that urban and rural station, so they combine them, they produce something called global temperature curve, which is the black line that you see in all of this panel. And then they use something called the computer climate models. This is a very, very specialized kind of area that I have to tell you that if the computer model can get agreement with the observation, I would say that you should be super concerned because you know already 100%, not 99.9%, that they got it right for the wrong reason. So you don't ever want to do that. It's just show you the state of this understanding of the physics of climate change is so difficult and the complexity that you know that it's just never going to include all of them in the climate model. I mean, John Clauser will talk about the cloud problem today, tonight or tomorrow, right, for you guys. And many other speakers here. I mean, Michael Connolly going to talk a lot more also about the situation of how much we do not know and how much do we know. So they use something called the hindcast. Hindcast is actually the opposite, right, of forecast. It's basically what should have happened in the past if we use a climate model, given something called the radiative forcing, the climate forcing, the factors that cause climate change. So they will have the man part of it, that will include CO2, methane, laughing gas, so on and so forth. And then the natural part of it, which is volcano and the sun, right? So things like that. It seems very impressive. If you look in details, this is what happened. If you look on the left panel, the black curve is the observation. The blue bunch of fuzzy curve, many of them, they say multiple climate models. That's really nice. All the models agree together. And they don't fit if you only use natural forcing, meaning only the sun and volcano. But then the miracle happened. If you add the carbon dioxide, that fit perfectly. If this is correct, I really laugh. If this is really correct, it's a very childish thing because this is called graphical kind of delusion. They try to make themselves believe in it. First of all, we already know that the black curve that they use is actually not correct. You shouldn't be using that at all to study this. So why would I believe you in the first place? But they don't even realize about that by now, of course, but we have published the paper. So this is how they conclude that it's mostly human cause. This is the standard. So remember, this process is to say what we call, instead of straw manning, we want to do steel manning, right? We want to explain IPCC, we're going to give them the maximum benefit of doubt. That's what a scientist should do. I hope I don't misbehave here, but sometimes I may say some very strong thing, but I try my best to be a good scientist, so try to learn as much as I can. Now, I just quickly, before we go even further, I want to show you another miracle. You all heard about how powerful these computer climate models, right? They have millions of grids. They can make grid size down to, instead of 500 kilometer to 500 kilometer box, they can go down to 10 kilometer by 10 kilometer. The Japanese Earth simulator is trying to do that. But the electricity bill is about $200–300 million a year, right? It's terrible. This computer model is actually very strong delusion. But my good friend, Willie Soon, he has spoken at this DDP meeting at least twice. He did a very simple experiment. So imagine that I think the yellow one is the observed temperature curve, the one that has urban and rural station. And then he said that if IPCC recommends so-called the climate forcing that have volcano, have a sun, have the anthropogenic factor, which is the CO2, methane, and nitrous, laughing gas, and so on and so forth. And then all he did is basically do a standard. We have a great statistician here, Warren. All they do is just do some kind of regression with some lag correlation. Just imagine, this is climate model has 400,000 of this line of codes. And 2 million grid cell, this and that, right? They always talk about non-linearity, chaos, this and that, the couple ocean atmosphere problem, this and that. But no trees, no cloud, no nothing. actually. That's why I say climate model, if you agree with your observation, you should very worry, okay? But it's just showing you this is the proof that what they're talking about is actually not worth even the word for it. It's terrible, actually. It's basically telling you that they're playing numerology. It has nothing to do with science. So, is the IPCC scientifically justified, right? So we have indeed published our group, led mostly by Ronan. He's the young rising genius around here. We are just, me and Michael is just, tagging along, trying to learn as much as we can. And we have two major points that I want to talk about, which is the land component of the so-called global temperature record, right? Clearly the answer is that those record has been contaminated by urban bias, by the phenomenon called urban heat island. So tonight, please watch the 9 minutes video that made by Ben to help us out in our group. So basically from his perspective of being a young person, we do want to encourage the people watching in the video to actually be more engaged. You see, even a Ben, 19 years old, can do this, right? And he's not even that interested in science in that sense. And then we are going to study the total solar irradiance, which is the solar forcing aspect that was recommended by IPCC, okay? Sorry, it's dragging on a bit, but let me keep going. The first thing I want to assure you is that we have published scientific paper, peer review, what have you. We can publish this paper. So in 2021, Ronan led this effort, and then we published and asking this very simple question: how much has the sun influenced northern hemisphere temperature trend? An ongoing debate, right? It's a very popular article in the sense that we've been cited, been downloaded 62,000 times. That's quite significant, actually. Normally, barely you yourself, like if you have 3 authors, I think 3 people have read or downloaded that paper. Now, if you have 62,000, that means there are some interest here, okay? And this is a group, have 23 co-authors from 14 countries, and we cited 530 references. I emphasize that point because I want to show you how comprehensive we are when we compare to the IPCC 6th assessment report that was published 2021. If you want to consider just the solar activity part versus the urbanization problem, you can see that IPCC cited about 96 paper. Because they always say IPCC is so comprehensive. But you just compare to our work, our paper cited 428. There's no comparison. These people are not serious because they always select certain part science that agree with them, they cite them. The one that don't agree, they just ignore it. It's very childish, actually. It's so obvious to prove. That's why I had to make this simple point, right? You call that science? Come on, man, give me a break. You know what I mean? That would be the John Stossel kind of move. So it's terrible. It's just not real science. And then another thing that I just want to put it up is just kind of nice. I saw this graph, somebody put it up. If you can dazzle them with your brilliance, you got to bury them with large number of pages. I really love for you guys to make a strong prediction. Can you guys predict what is going to happen in the AR7? You bet the number is going to be higher, isn't it, right? No way it's going to be less. This is the kind of standard golden rule of bureaucracy. But anyway, let's go on to the detection process. Yes, we will study about the land surface temperature, but in the process, we also show you that how our rural station, when we consider just rural instead of urban to avoid that contamination problem, we can compare that with the sea surface temperature. We have limited information, not very good, but limited. But we can show you how they all correspond to each other, isn't it? So urban heat island effect, what is it? Again, please watch the video tonight. This is a well-known, famous city on the hill. It's called Washington, D.C. This is where all the problem begins, right? Major problem in terms of funding. But anyway, this is the urban heat island. It's very well-known. The red area means that it's very hot, right? And the temperature, the magnitude is very large, by the way. These are at least 10-degree kind of difference. And then the blue area are the cold area. You can see more vegetation. It's just basically concrete versus the, the green area, basically, right? So, in terms of numbers, we know that this urban heat island effect is real, isn't it, right? It's real, absolutely a real phenomenon. But it is the local climate change. It has nothing to do with global climate change, right, in that sense. And we know the magnitude can be very large. I would give a number of 2 to 15 C. If you multiply by 1.8, you know that will be convert you to Fahrenheit. That will be large, isn't it, right? Up to, we're really talking about a very big number. And that's so much larger compared to what you call CO2 forced climate change. So it's just something that is weird that they don't want to talk about this. They kind of say the effect is small. This is how IPCC has been manipulating and hoodwinking a lot of people in that sense. Okay, urban heat island is known, really known for a long time. It's not new kind of concept. It's known since 1800, 1820, 1810 or so by a guy named Luke Howard from London. I mean, he's actually a pioneer in meteorology, by the way. All the cloud classification system was started by Luke Howard himself. Cities are indeed getting bigger. Urban heat island effects also are getting bigger too. But indeed, urban area is cover only 2 to 4% of the world area, right? And but then 75% of all the weather stations come from urban area in some sense now. So this shows you the problem that we have to face. And then even more important is that most people do feel this so-called heat in that sense but almost half of the population, according to UN, already live in the cities, right? Big city, urban city, mega city, you know, Tokyo, Shanghai, you know, New Delhi, all these kind of places, and even Bangkok, right? So it's a big effect. And this is the part that I want to emphasize. We try to show you on the left, basically distribution of thermometer data available in 1880. So that's more than a century and a half ago. And then on the right is year 2000. There's a lot of data now, but you can see in the past. Can you say that you have global temperature back to 1880? I don't think so. You have only mostly thermometer record from North Africa, from Europe, and then from East Asia, essentially, not much else. So I don't think so. That's the idea why we use Northern Hemisphere record, by the way, right? So in that sense, it's really true. Now I want to make a very special point here. We're going to talk now about individual thermometer station. By the way, we won't talk about 8,000 of them today. We'll just show example that places that Ronan have been and personally verify. I hope you bring your detector there to measure, right? But anyway, the point that we want to make here that even in rural station, you have to kind of worry about what happened in the condition because things can change, right? You can change either using the type of thermometer you use and then how often you go out and measure them. Because someday maybe the guy that observed that have too much beer so he forget to go out and measure, right? And sometimes he keep going out. Local climate influence, buildings and trees built around the area. This is the kind of problem with the thermometer data, right? And then station can move, right? From this place, let's say from here, moving to the outside of the hotel, places like that. So something serious. So for now, we will use one example. Since I'm essentially Irish now, so we're going to use the Valencia Observatory from Ireland. This is a very famous place, by the way. The transatlantic cable started around here, right? So 1867 to 1892, the location of the thermometer station is actually way out there in the Valencia Island. And then in 1892, they start moving inland at the location. And then since 2001, they move even further inland, which is about 350 meter inland. And then, but the most important thing is 20 meter higher, okay? What we're saying is that if you actually have a thermometer record, right, which is what is shown on the left there, the tiny little puzzle, you actually do have to worry about all this movement and changes. You do have to correct them. In the sense that so-called raw thermometer data, you're not supposed to use them. You really need to understand individual states and the history of what happened in that particular thermometer data. So you do need to do that. In Ireland, you can see all these major changes, of course. The most important thing is 1937, where the Ireland become the Irish Republic themselves, right? They are proud independence from the UK tyranny. Well, anyway, so indeed you do have to correct for them, isn't it? That's the point I want to make. And then I want to contrast with another way of people doing things. It's very fine in science that everybody have different way of approaching a problem, but now we want to introduce a very famous one, which is actually the only one people are talking about, which is the NOAA adjustment scheme. NOAA stands for the US National Oceanic and Atmospheric Administration. They have a group, that's a very strong group that provide all the data that people are using, by the way, to say that maybe we shouldn't worry about the station history that I show you, the Valencia station moving in and out. We use this something called a statistical adjustment, this statistical homogenization, meaning that if a thermometer sitting here and is something nearby, let's say a miles away, they should have similar trend. That's basically the concept, right? All of that should, so that you can detect all this so-called non-climatic change. So that's the idea. It's not a bad idea at all, except whether practically does it work, right? That's a whole problem. And now we want to show you, same thing with the Valencia station, that we know that we only need to adjust for the 2001 because we know when you move inland and then the thing is higher, so it's slightly warmer, so you need to adjust that and bring it down. Yes, that's a fair thing to do. And that's what you must do for every station, isn't it? Even for the rural station. Urban one is a bit harder, that will show you how you tackle those problems. But this is what IPCC, the NOAA is doing. From the statistical adjustment, those are all different dates in which we got the data. From 2011, some March or October, and then down to 2015, January. You can see that every time you have a new data record, like the adjusted, the update is because there are other stations. People update the whole so-called global historical climatic network. The station, the data coming from NOAA. That every time there's some update from meteorological agency or Zimbabwe or something they put in, then they update the data, they run this statistical algorithm. But every time they run, they're different. The adjustment recommended is different because it's statistical. They don't even check with the station history. In fact, they try to say that you don't need the station history. It's a very puzzling thing. I'm not saying this for fun because we have actually very, very lucky to be able to do this, by the way. We are very lucky in the sense that Michael and Ronan met this guy named Peter O'Neill. This is a great, great guy, this guy. He was interested more or less in a few stations in Ireland or maybe somewhere else. But then he started collect about 6 of the version of the GHCN, which is the NOAA temperature record over the globe. You see, 2011, he has only 6 versions. That was version 3 and then version 4, and these are all meaning more updated. He has 6 of them, and then he noticing things are changing. So you can imagine, he keep collecting. I'm sure by 2024, he would have more. We will have to update. So over 2,000 versions we have now. Of every time they update, we have a version of this record. But the question is that, is this version from yesterday versus today, is that the same? They are different, okay? So we published a paper in 2022 focusing on Europe, okay? In Europe, we asked a whole bunch of people that are willing to work with us, can you give us the station history data? These are all people who believe in IPCC, by the way, okay? But they are willing to learn about science. So they give us the station history data. We back them, of course. I would back. I would go down on the floor, please, for science sake. Let us have the data. So it's the red dot here. There's a lot of stations from GACN, but 800 of those, the red dots, okay, are the one that we have the station history data from all these different European meteorological agency, basically. Individuals that work there, willing to work with us, okay? So the first thing we do is basically ask a very simple question. If you have a few thousand versions of this, let's ignore the station history first. You just ask, every time they run this algorithm, are they consistent from the, this version, next version? We found out that it's only 17% of those adjustments apply consistently. That means that 83% of those are completely, sometimes it's this, sometimes it's that. It's just crazy. This is very, very bad, by the way, for them in that sense. And that's the fact. We found this. If we did something wrong, please let them come and tell us, right? And then another thing we do, then we check. Every time you apply this adjustment, let's say in January 5th of 1995, you do this adjustment, is it consistent with what the station history of the station? We have 800 of those stations, so we can check that, right? We found that it's less than 20% of them are agreeing with the actual history is recorded. I hope you know how significant this result is. No wonder they don't want to talk about this. There's another issue that I want to talk about is, we're not going to go in detail, but it's a paper, that's a very beautiful paper. It's describing a problem called urban blending. This is the part of homogenization, right? You try to make sure that the neighboring thing agreeing with each other, but every time if you have a little bit of urban kind of biases in that station, you will contaminate actually everything else, okay? This is the problem that is really existing. So when the caution here is that if you use the thermometer record, you should not use so-called massage homogenized version, okay? It's not the milk that you drink, by the way, but this is a very bad thing. I mean, in principle, some of this adjustment is interesting in the sense that it's good because you reduce the step jump, this random jump, because it's artificial. But then the contamination problem is very huge. And in that paper that basically Ronan and our good colleague from Japan, Genki Katata, actually show that this thing is a serious problem for Japan and the US thermometer record. Again, we are waiting for them to engage with us. Obviously, I'm waiting, Al Gore, if my phone is always open, call me. So now, what is our solution? Our solution is that don't look at the urban data. That's the first cut. We can do a lot more things, by the way. The first cut we did started already 2015, where Ronan immediately said that, why don't we do that? Okay, man, let's do. So we got all the station here, which is the 10 to 15% of all the data available, because large part of it is all the urban involved. But this 10 to 15% cover 90% of all the rural record we have that can go back to 19th century. Okay, so the first cut is that, what are we going to see? Here's a summary. You see the top graph is the one that use urban and rural together, and the bottom one is the one that use rural only. By the way, the curve now is not annual, so we smooth by the 10 years, kind of 11 years filter to make it smooth so that you can see the trend and changes. And clearly that from this one result itself, if you compare the long-term warming trend of the top curve and the bottom curve, you can see that it's far more than 10%, less than 10% that the IPCC is saying. So completely we show that this is easily shown. Do you understand? Because they claim the urban effect is nothing. It's so small that the two curves should look the same. But even more important is that the warming character is so different. Notice this one is kind of small, and then the 1930s and 40 warming is nothing. And even the cooling of the 1970s, which is well known, because people are talking about ice ages are coming, I mean, it's nothing. But the one that we have is have a cooling and a cool and then go warm and then cool again and then warm up again. So it has a kind of oscillatory or periodic kind of a character. So the way you explain this thing will be very different in that sense. So we'll show that in our later results. So in that sense, weather station, despite how bad it is still the best we have, because at least it's sitting there in some certain location and then trying to record something, okay? All we need to be careful is actually know the station history that is non-climatic factor, so we can get that out to see what signal can we have. And then of course, sea surface temperature is another good one. But sea surface temperature is kind of also bad in the sense, but we still do what we can, whatever the data we have. The most important thing in science is that if you don't know some quantity, you want to see how large the error bar is, isn't it? And error bar here, we mean real error bar. We're not talking about the Stephen McIntyre, Ross McKittrick type on the hockey stick error bar that is fake. Those guys were talking about Michael Mann's work later. But we have 3 rings, we have the glaciers kind of record. So we want to compare now how good our rural only temperature record compared to the other measurements that we have. So on your top left is a rural only temperature record, right? Cooling, warming like that. And then if you look at the sea surface temperature record, it has more or less the same feature. Cooling, warming, right? And this warming definitely doesn't mean that it's going to be indefinitely warm, right? And then you can see 3-ring proxy, you can see the glacier length, and then most of the other record, like the balloon data, which Michael is going to talk in details, even the satellite record, they are much relatively shorter. So they can't address this so-called 50 years, 60 years, or 100 years change, a short record, right? But they are consistent with what we see in our rural-only temperature record, okay? To tell you that, to prove to you that IPCC at least once was a bit sane, you know, the first report that published in 1990, they actually admitted that the 1920 and 1940 warmth is natural, is large, that it is probably very natural, have nothing to do with CO2 or aerosols and this and that, right? Because you know that they're very clever in providing tricks. But I want you to be assured that what we did is within the bound of IPCC. All the character that we just saw totally agree with what IPCC say, but except in the first assessment. Because in terms of bureaucracy, they have to make sure that human is there solving every problem. Then there's another very deep problem. Probably this data will bore you, but this is not real data. This is what you call the best understanding we have. Even though I criticize model, model has its own limited use in that sense. This is basically what you call assimilated data, basically. In a very sophisticated models, that you can see that the ocean heat content itself have this warming in the 1930s, 40s, 50s, and then cooling and then warming again. It shows you that the character that we saw is a real thing in some sense, okay? I'm not trying to say that this provides justification, but I try to tell you that we have this strong internal consistency. Now, let me move on quickly to the attribution, okay? If you have global warming, what caused it, right? IPCC, of course, put something like this called the radiative forcing, so everything is on the same units, watt per meter square. That's something that we should know. And then they try to do hindcast, which is, of course, backward projection, to try to see that if you use two natural climatic factors, solar and volcanic, and then for the human part of it, I want to tell you that they have 11 smoking guns. This is a very clever design. They have the CO2, they have the methane, they have the laughing gas, they have contrail, they have this and that. And then aerosol is one of those strange things, by the way. Aerosols in the natural world, there's at least 100 different types of aerosols. Basically, all these tiny particles, right? Anything from, I would say, micron, nanometer, 10 to the minus 9 meter, to millimeter and things like that, right? Dust particles and this and that, all right? But they only consider sulfate aerosol, specific type, because combustion engine release some sulfur, and this sulfur, chemically reacts in the whole thing and then turn into sulfate, only sulfate, which is a puzzle, which means they pick and choose. It's an amazing thing, actually. Contrail, even what did they consider? Black carbon. There's another thing called black carbon, okay? This is another one of those. And so, if we think about the natural one, look, volcano and solar, all plotted on the same scale. You see, you saw that one? You saw that? It's all plotted on the same scale. The solar, essentially, they say is like this. I will explain in detail what this means. This means that we should close shop and everybody go home. IPCC win, will give them a Nobel Prize and all the medals, But volcano one is another problem, by the way. I really felt bad for volcanologists. They don't speak out. They let people abuse and tramp on them. The volcanologists. They are saying that their curve will look like this. I absolutely say, hell no, it's not like that. Because it's a very difficult problem. Did you ever see two volcanoes that emit the same thing and do the same stuff? They don't quantify how much water come out from the volcano, chemistry, the dust, this and that. What's the height of this thing? They turn into something called radiative forcing. So impressive, basically. It's very convenient. See, the problem is that when you make your assumption, you got to not forget what your assumption is. IPCC is just that kind of wild gangster. Just run all the way to the end. I win, I win, I win, I win. But they don't have anything to show for. So if you compare anthropogenic versus volcano versus solar, you can see there's nothing to talk about. They win. Except that their solar part is a big problem, which I am not going to explain because I have been working on this solar problem for a very long time, at least 30 years. I'm very slow, but we're beginning to make some progress, okay? With help of Ronan and Michael, it's just amazing progress we can make. This is what IPCC is saying. They use a stick, they forget the matches though, by the way. We need to supply the matches to them. Now I want to introduce to Mr. Bob, right? Mr. Bob, the bright orange ball out there, right? And they try to say that this is the standard theory, is that the sun cannot cause the climate change. Cannot, not possible, no way, Jose. Here's what it is. We have to remind us, so every time you give a talk, don't be afraid to show this kind of graph. In terms of total power estimate, you have a particular number, 4 times 10 to the 26 watt. And then if you compare to the earth, how much power do we get? It's at least 2 billion times weaker. And even that part of it is actually come from converted sun energy onto the system that can move the ocean current and let the tree grows and this and that, right? The wind blowing, all this stuff, okay? And that is just a converted energy. If you actually want to estimate how much the intrinsic, the energy coming from the earth itself, is basically radioactive decay kind of measurements. And indeed, physicists has been doing some good work. They've been estimating this thing. It's basically measuring well, there are 3 experiments they estimate, but even that is 10,000 times weaker than actually the converted sun energy, okay? They measure the Earth geoneutrino, so-called geoneutrino from the core. And these are very interesting experiments done in Italy, Borexino experiment, and then Japan has one experiment, and then China is also trying to measure this. And this bound is very good. Within a factor of 2, you can get the number. Reasonable. But it tells you that the Earth have any intrinsic source of energy. This is why I keep telling Al Gore, you say the Greenland ice sheet is going to melt, but it's not going to melt. If you imagine the ice age, common ice age. Let's say 20,000 years ago, Boston was 2 miles thick of ice. Imagine Al Gore used his CO2 laser trying to melt the whole damn thing. I mean, what's going to happen, Al Gore? There's no energy. This thing is not an energy. CO2 is not an energy, of anything. The only thing CO2 does to the climate system is actually to reduce the rate of cooling. That's about it. It's not a pure form of energy. The only source of energy is actually solar, the solar sunlight, UV, and the visible light. So the question I want to pose here is that could they have underestimated the role of the sun? It's not rhetorical. It's a serious question, isn't it? First of all, they cannot overestimate, right? You know that. So, that's good enough. Just to introduce you to the most important feature on the sun, which is sunspot. Okay, what's obvious about the sun? Long time ago, but actually when I took up my postdoc position at the Harvard Smithsonian, I don't know what a sunspot is. I admit it openly. That's how stupid I am. I was not educated at all. So I learned, and then I ended up writing a popular book on the sun, of course, which I dug really deep and learned as much as I can. So you want to study things like the sunspot, and these are examples of very large sunspot that just appeared very recently, a month ago, or less than a month ago. And then this one, I just couldn't help it. This is the collection of all the sunspots that appeared in the last 6 months, right, of the 2024. It's kind of beautiful in that sense. You can see the exclusion zone in the equator. There's no sunspot could be formed there. There's a certain fluid dynamics problem that to explain why this is so, right? So for studying the character of the sun, you need to know small spot. You need to know the small sunspot group, which is much larger. By the way, if you put the Earth in there, you can put 110 Earth across the sun diameter. If you do in 3D volume, it's about 1.3 million Earth you can put inside, pack inside the sun. So sun is a significant object. It's the energetics that is very, very important, isn't it? So we want to know how you go about estimating the sun irradiance, right? So we do know, since Galileo Galilei pointed his telescope, right, that we have some data about sunspot actually. And then it's been going up and down. The famous one is the 11-year sunspot cycle, up and down. But no two sunspot maxima are the same. In fact, no two sunspot minima are the same. The only problem when you are minima is that you sunspot because you count number, there is a zero. So when it's zero, it's zero. It doesn't mean anything, by the way. And that's what I'll try to explain to you, why this using sunspot number is not a good idea. You need to study the character of the sunspot. I did show that you have to study umbra, penumbra. Umbra is this straight magnetic field, very intense magnetic field region, up to 6,000 Gauss. And then the Earth average thing is only half a quarter. So it's about 10,000 times even stronger than the sun's magnetic field strength. And then umbra is basically slanted magnetic field on the sun. So you need to study the character of all these things. And with a lot of work, okay, we are working very hard to try to learn how that manifests in terms of integrated sunlight coming out from the sun. That's a very hard measurement. We will show you the problem. But essentially the sun is a multi-wavelength between multi-color emitter. Right? We're showing you the white light and then the magnetogram, and then you have UV and then the X-ray, jump in very different character. The task is that can we find how much the total integrated sunlight is? We have done this experiment. This is what the satellite era. We put up instrument on satellite carrying this little thing called cavity radiometer. Right? It's a black box, painted inside, little pinhole, trying to measure those things. And this is the experiment we have done so far. We only put like maybe 12 or 13 inside here, all the different experiments, this is really hard measurement. You cannot do this. The Smithsonian has tried to measure on a mountain in Chile and places like that. But most of the problem about Earth physics is that it's basically the cloud problem, really. You see from the ground, you cannot see anything. So you got to go up in space and do these measurements. But even when you've done all these experiments, look at that. Each one of them costs $200 million. I think this is a very expensive experiment. But you can see the values are all over the place. Right? You do have a hint of sunspot cycle behavior for individual cycle, but we don't know exactly how every cycle compared to the next cycle. That's the whole problem that we want to solve. It's a very hard problem. We don't have solution yet, but we kind of know what to do next in some sense. Well, here's the consequence. I want you to focus on only the middle panel there, which is called PMOD. Okay? It shows you the actual so-called PMOD produced. So this is one group attempt from Switzerland. They're trying to produce what is the TSI, which is the measurement of all the satellite. They adjust all the satellite down, they put them all together. It is so flat that when you try to scale it with the sunspot number, look, they match exactly. It's a miracle, actually. This is a miracle result. By the way, the owner of this guy, he already just passed away 2 years ago, so we will continue to explain how he got this result. There's a paper undergoing now, review led by Ronan again, brilliant Ronan, that we actually find a way to explain this. This area of science is so bad that you have to explain so much of the history and so much confusion. So it takes a lot of work. Every time we write a paper, it's getting more and more expensive. 60 pages paper, and then you have to pay for the paid charges, ridiculous actually. We don't want to write long paper. Believe me, I am a physicist. In some sense, I want to write very short paper. I prove, therefore I am. Well, anyway, so there's another very interesting group from NASA JPL called ACRIM, A-C-R-I-M. The red curve, focus on the red curve. Look, they show you that the minima are different. Actually, the consequence is very simple. Since I ran out of time, I'm going to tell you. This is the IPCC approach on the right. They basically say that the sun irradiance change like this. Here, the minima change a little bit, but the group from Belgium, Royal Observatory of Belgium, essentially have it calibrated to the sunspot number, which means every minima is the same. As far as I know about the sun, there's no two minima are the same. This is a very ridiculous result. I would bet my whole money, my whole thing on this. I think this is wrong. The slightly more interesting result is this one. I don't say this is correct, by the way. This is including even more proxy. Instead of just sunspot, remember I told you that you have to use umbra, penumbra. You have to use so many things. There's many things, like there's a bright region called faculae. Sunspot is called maculae in Latin, right? You can measure that. You can actually try to document how it changed. And this is one of the product, okay? I don't make any particular bet. All I know is that there are alternatives. But IPCC say, don't look at that, don't look at that. Close your eye, please close your eye. Keep walking towards the cliff and don't do anything. It's ridiculous. So we do have 27 pieces of Paso, which is the 27 different versions of the sun, total solar irradiance, TSI. And this is all of them. Don't stare into it, but essentially 8 of them we calibrated with ACRIM, 15 the PMOD, and 1 so-called community, and 3 sunspot number base. All of them, we just put them there. This is when you do science, you have to study all of them first until you can rule out, see which result are the totally impossible one, then you have to throw them away. Right? But so far, none of that can be thrown out in that sense, right? But I kind of don't like the sunspot number, but don't like doesn't mean anything. You have to prove it. So which we are working towards next. Now I want to explain about history of how IPCC considered total solar irradiance. In 2007, in the 4th assessment report, they actually recommend 6 to 10 TSI record, okay? And then if you move on to the 5th assessment report, which is 2013, they consider 4 of that. I guess you already know by now in the 6th assessment result published in 2021, they recommend 1, nothing but 1 and only. Think about it. What happened, IPCC? Can you explain? Because some solar experts say this and that. There's no solar expert in the IPCC co-authorship, by the way. It's a very strange phenomenon. How can this thing happen, actually? I don't understand it. Please, someone explain to me. IPCC, I'll go, I beg you, How can you say that, right? It's completely nonsense, actually. And then I want to remind you, there are 8 of this. All of them are still cannot be ruled out. In science, you want to rule out something, like it's not possible, right? So let's study them. But I want to pause here now. You really think that IPCC is correct to consider only 1? Please answer it for yourself. And also, if you don't believe that this is correct, I think you should speak out, use any of this graph. If we are wrong, we're willing to admit it. That's the first thing we will do, because we are scientists, okay? But we are sure now IPCC, this particular thing is not sustainable. It's just something that I have to throw out. So IPCC, if you're listening, we are still here. Yeah, I'm that serious. 97% of scientists agree, whoever is funding them. This is that serious, because this is the problem of funding, by the way. Because people are not thinking. It's very strange. All the young students, I hope my 2 sons won't become like that, or else I'll disown them myself. It's terrible. Don't be like this. You just got to learn the truth. And then I want to report now the final result, which is based on these 2 papers we published, September 2023. And think about how, this one is even more people downloading. This morning is over 78,000, by the way, so I didn't update that. And then another paper led by Ronan is also 10,000, very significant. People are downloading. And in this particular paper, we basically throw all the picture out. We consider 27 TSI, 5 temperature proxy, which is the urban and rural only, sea surface temperature, 3 rings, and the glacial line. And then we study them. So we study, by the way, this is not, it's not because I don't like physics. this is the level of playing is only on the statistical level. So we're doing statistical correlation. Yes, I'm proud to say we're doing that because we don't understand. That's the problem. So we study this with the 27 TSI and 5 temperature estimate, right? So let's focus in on the rural only. We can show you quite a few of the irradiance estimate can actually fit this rural only very well. On the left there, which is the red line, is the one that only consider the CO2 forcing, the greenhouse gases, the IPCC anthropogenic forcing. And then this one is sun only, just to contrast them. We don't want to put volcano in because volcano is also kind of a strange thing. But you see that? We can explain that. It's not bad. The sun really is still able to explain all of the signal. And then for sea surface temperature, same condition. IPCC can fit only 1/3 of it. You can imagine the last chunk of it is not explaining. Please do not go and shout that I am the winner, I win when you have only 30% out of 100 in your score, right? It's kind of not good, embarrassing. Anyway, IPCC is so uneducated in the first place, but 3 rings is like this, same story, okay? Please read the paper. IPCC, you're welcome to criticize and read them. So let me conclude. The first point is that the claim that urbanization bias is less than 10% is just wrong. There's no way about it, no if or but about this. We are very confident of that. We'd like IPCC to correct us if they can. And then on the TSI, the total solar irradiance, they say use only 1. We say 27. That one I'm confident too that they are wrong. Okay, good luck IPCC. Another thing is that, yeah, indeed, if we were to consider all this alternative TSI, alternative temperature record, you really can explain most of it by the sun alone, as of even 2024. This is no joke. No wonder this is such a challenge to IPCC, but we are not set out to challenge IPCC. All we want to know is that what are the facts? That's what we're doing. And then bottom line really is that you cannot conclude yet. Global warming is mostly natural. You cannot also conclude it's mostly natural. You cannot conclude it's mostly human cause. We really don't know that much. In science, the hardest point is to say is I don't know, okay? So in that sense, I want to turn philosophical and end my slide in another 2 slides. This is somebody that I really admire, Professor Freeman Dyson, that died in 2021. He said that the central mystery of climate science is actually not science. It's actually about human mystery in that sense. Because it is the people who are supposed to be expert, who claim to understand the science, are precisely the people who are blind to the evidence. How does it happen that the whole generation of scientific experts is blind to obvious fact? Think about that question. And then we're going to have this well-known quote by John Clauser, which he boldly makes this statement. I can tell you, John, Goma Pao, reporting to duty. I'm so happy to see this because you are right. The IPCC is one of the worst sources of dangerous misinformation. And this man boldly, boldly say that in the public conference in Korea, South Korea. I mean, it's very, very nice. And we are so proud when we hear this because at least we know there are scientists, science is alive. There are some scientists willing to stood up for the truth, right? Say something. Instead of just sitting around and then, IPCC did and that. We know all of that. We shouldn't be complaining about them. But anyway, one final plug. We've been playing a lot of soccer game. Right? Let me show you where the ball is, but Ronan is there. He's handling the ball now. He's passing to me, and then we're passing to Michael to kick the goal. Right? European Cup is going on, and Germany is out, so very nice. But anyway, we're playing this for a long time now. You can say the score is still 1-1, isn't it? We score a goal. We did score a goal. Definitely. I feel good, you know, in that sense. But it's not a game. It's really not a game. It's actually about something much more serious. This fundamental problem of climate science now is also the funding. Every time we write a paper, we need a few $1,000s even to pay for open access, just to be able to compete with this NASA, Gates, Gavin Schmidt, all this big guy, Michael Mann. Every of their paper are available for everybody to download. We have to compete with them to make our paper available in public too, which means we have to pay. They got the funding from our taxpayer. I'm helping them actually. And you see how imbalanced it is? So I do call for some help. If anybody is interested, but actually not the money, please spread the message, which is far more important to me. We survive, you know, my 2 kids eat a lot of buffet. Look at them, they're pretty chubby, they eat a lot. So they're okay. And please help us. If you can donate, be a monthly subscriber or something, you know, like donate, you know, $10 or $100 a month, you will help us a lot. Because every little amount of money we can get will go a long way. Believe me, we don't abuse money. We really know how valuable. Everybody is poor now in some sense because of Biden, so I can say that. Okay, I think I finished my talk now. Thank you very much.